Okay.
All right. So I have a question for all of you today. Most of you probably flew here, but how many of you had parents that walked to school? Sometimes uphill, both ways in the snow. In fact, we used to always walk everywhere. If you wanted to go somewhere, you walked. That was the one option you had. You didn't have another option. But now you have choices. Here at reInvent, you could walk. I put in about 19,000 steps yesterday. You could take a bus. You could take a cab or an Uber. You have choices at how you get around here and in life. Now, when we think about backup and disaster recovery, for the longest time, we had one way of doing that process. We took our data, we copied it to a tape. Sometimes we copied the tape, put the tape off-site. We always had one way of doing that. But in today's environment, you've got many more choices that you can make. Do you achieve DR? Do you use backup? Do you use resilience or availability? And how do you deal with compliance? So we're going to talk to you about how to make some of those decisions today and how you can do this in your environment. Now, my name is Mark. This is my friend Yaniv. And we're going to go through some of the ways that we help customers on a day-to-day basis as they make those decisions.
Mark mentions that you have choices. And the thing is, there's more than one way to get to a right answer. So we'll start with looking at some of the basic factors that will help you to understand what is the right tool and approach for your organization. So we'll start with some basic stuff that I'm sure a lot of you saw before. For example, how many of you saw this slide before? Yeah, quite a lot. We often use it, maybe too much, but I think it's because the mental model that it represents, it's really important for when we talk about data resiliency and data protection. And it goes like that. AWS is responsible for the cloud. So in the context of data protection, the resiliency of the cloud, while customer is responsible for the data that you have in the cloud. And we are responsible for regions, AWS is responsible for the regions, for the availability zones, and whatever inside of it, the patching, the physical security. And the customer is responsible for the architecture that you put in your account, what networking that you put in, what approaches, what solutions and tools that you choose. But one thing that is very important that the customer is also responsible on is making sure they are compliant and making sure that they test the data. In fact, it's so important, but it's often overlooked. So we're going to say it twice. It's really important to test and make sure that you're compliant. I have a friend, then many years ago, was in a company that used tape backup. And they had a disaster, nothing too bad, but when he went to actually restore from backup, the tape was full, and in fact, they didn't even back up anything for months. So you do want to make sure that your data is available once you need it. So testing is really a key, and we keep emphasizing that later on. So the next basic concepts that most of you, or all of you probably know, is RPO and RTO. RPO is recovery point objective, is how much data you can afford to lose. How fresh is going to be your latest snapshot? And RTO is recovery time objective. How much downtime can you afford? How quick should you be back up? And of course, we want them both to be as low as possible. But a trade-off with how low they are have big differences on how much we pay and what complex is going to be the solution that we will choose. So on one side, we can have higher RPOs of hours, RTO of hours, and less complex solution, and that's going to be backup. You can have a more advanced solution with better capabilities and lower RTOs and RPO, and that's going to be disaster recovery. And on the other end, you have high availability. And that can be very complex and also very expensive, but it's almost real time. So there is a question. How do you choose which one of those choices you're going to use for your workloads? Mark?
Thank you. So the first thing you want to do is tier your applications. Once you know your RPOs and RTOs, you want to understand how to group them together. Standardized tiering. Now, I've worked with customers that have 19 tiers. I've worked with customers that have 1 tier. I would suggest to you that 1 is too few, 19 is probably too many. Start with 4. It's a nice place. But what I want to make sure you understand is that most of your environment is not going to be tier 1 or tier 2. 30% or so should be in that fastest time to recover, lowest recovery point objective. Now, when we look at which products from AWS you might be using to achieve these different tiers, DRS, or Elastic Disaster Recovery, is a great solution for those tier 1 and tier 2 environments. And for tier 3 and tier 4, AWS Backup. Now we're going to go into a little more detail about both of those. But first, let's talk about DRS. Now what is DRS? It starts with an agent that you install on all of your servers, on-prem or in the cloud, including AWS. So if it's an EC2 server, you protect it with this. We send that data to another part of the AWS cloud or to the AWS cloud continuously. So as data is written to it, we copy it as fast as we can through a process that we call continuous data protection. And then the service automates the creation of the EC2 servers and the EBS devices that you're going to need to recover that. So this is a fully automatic process. But wait a minute, earlier you said that we protect the cloud, but I just said that they have to protect EC2 servers. How does that work?
So let's talk a bit about the basics. Let's take a step back more. And AWS has 34 regions worldwide, and each region has at least one availability zone, which is at least one data center, and it's isolated for other availability zones. Those are your building blocks. As you build your architecture or your workload, or placing your workloads in different regions and availability zones, this is the way that you can build resilience workloads. Now, Mark was right. You brought your data to AWS. You actually are in a good place. You actually put your storage in a place that it has redundancy built in and durability. Yes, we do those tests, we do those audits, and we store on redundant devices. But there might be situations when there's going to be water damage, there's going to be fire, there's going to be earthquake that can cause you to lose your data. And it doesn't have to be a force majeure. It can be that your application data are going to be corrupted. It can be just honest human error. It can be a ransomware, somebody maliciously getting into your environment and corrupting your data. It can be a bad policy change that can delete your data. And AWS has to honor deletion requests. And it can be bugs. And infrastructure can also be corrupted. And in the AWS world, your EC2 instance can be bad and have a failure, or your database can have a failure. So you need to be ready for that. And then in addition, as we mentioned, there can be force majeure. There can be natural disasters. There can be AWS disruption that can get a region down or an availability zone down. So we need to prepare to protect our resources. So how do we protect our resources? Well, the answer is, of course, it depends. And it might vary a bit between what type of resource you want to protect, but the best practices are universal. And there's a lot going on this slide. And what I want you to take from this slide is that, first, as a best practice, you should have a local copy for tactical response. You should have a remote copy of your data for disaster recovery. And you should have a vaulted copy for cyber resiliency. And we'll go more into that later on. But in this slide, what I do want to focus on is on the top left side, which is block storage. And the reason is that EBS, which is AWS Block Storage, is a single availability zone resource. And we need to make sure that it is resilient if an availability zone fails. And also, most of workloads are server-based applications still. And server-based applications run with block storage. And most migrated workloads from on-prem usually are block storage, EC2, and EBS. So we need to think, okay, how do we protect our workloads? And it starts from a foundational level, that we can just take snapshots. And AWS has tools like Data Lifecycle Manager that can schedule snapshots. And we can control how we block access, unwanted access, or at least take precautions to block it. But we can go more advanced. We can add a disaster recovery solution on top of it. A disaster recovery solution not only give you now lower RPOs and lower RTOs for your top tier workloads, it also gives you the ability to test without disrupting to your source environment. And that's really important when you think about doing audits and making sure that you're compliant, especially if you have regulators that require you to show that you are protected without disrupting your operations. And then you can go comprehensive, and you can add a backup solution to it. And we saw that you can go to a vaulted and have a vaulted copy of your data, which will help you to respond to a cyber resilient. And more on that. AWS offers several tools that enable you to understand how compliant you are and what resilience posture do you have. But we have also great partners and third-party tools that provide those capabilities. So we spoke about that. We took a step back. Now let's go back and talk about which approach we should be using in AWS.
So Yaniv showed this slide earlier. It was this idea of you had different resilient strategies. And they were discrete choices. High availability is not backup. Backup is not disaster recovery. But when you start to use AWS for disaster recovery, we have something that wasn't available to you years ago or decades ago. We have elasticity. So our clouds have lots of spare capacity in terms of disk, in terms of bandwidth, in terms of compute power. And because of that, now you don't have to choose a discrete option. We've got much more of a gradient framework. In fact, we have new capabilities in a cloud disaster recovery strategy like Pilot Light or Warm Standby that you used to sort of be able to do, but only with very expensive configurations. And now, with something like AWS Elastic Disaster Recovery Service, you can start to get the costs of Pilot Light, the time objective of a Warm Standby, and the recovery point objective of almost a high availability solution, all for that low cost of a Pilot Light configuration. So this takes what used to be your on-premises disaster recovery solution, where you had a recovery site that was just as expensive as your primary site, and now we've converted that through a cloud-based recovery option, where that cloud-based option is much lower cost to you. And in fact, we have many more patterns that we can use. So it's not just on-premises to AWS. It's not just other clouds to AWS. We can protect between regions. We can even protect between availability zones. So you can take a single workload that's running in a single availability zone, automatically protect it to another AZ, protect it to another region, protecting other cloud workloads to AWS, or your on-premises workloads to AWS. Now, AWS Elastic Disaster Recovery has 5 key benefits. We really talked about the first 3, the faster recovery, the lower cost, data protection. So I want to talk about the last 2, easy testing and ransomware recovery. Now, testing should be part of the life cycle that you are using when you configure, deploy, and run a disaster recovery product. You set it up, you do a test, then you're in an operational state. In case there's a failover, you pull the switch, fail everything over to your disaster recovery site, fail back. But testing isn't a one-time thing. It's something you need to think about on a much more regular cadence. Sometimes it's annually, sometimes it's more often. But the other thing that's come up is ransomware recovery. So because AWS Elastic Disaster Recovery Service is built on EBS and it uses snapshots, snapshots are natively immutable. So it's a great way to recover quickly if you have a ransomware situation. We also have great abilities to do account isolation, to separate all the accounts from each other so that your production account and your disaster recovery account aren't compromised together. We also can integrate with existing endpoint detection and response tools that are available from some key AWS partners so that you can start to find out exactly when you've got an event and then go and look at how your recovery inside DRS is going to work. And because we give you that point-in-time recovery of a snapshot that is collected for as long as you configure that for, you can go back in that point in time and do that recovery quickly. Now, I talked a little bit about how the AWS Disaster Recovery Service agents work. You install them on your existing servers, whether that's physical or virtual or cloud. We send data up to the AWS cloud. Now, once it's in the AWS cloud, it sits in what we call the staging zone. So in that staging zone, you've got a VPC, and there are EBS volumes that are attached to staging servers. Those replication servers receive all the data from your sources and keep it on an EBS disk. And then once you need to recover, click the button, and we create the resources for the recovery target server and the recovery target devices, or the EBS devices. Now, all of this is staying within your account, so you control all of this. It's encrypted according to your policies with your encryption keys, but it's doing so all in your accounts. We manage the replication server images for you, because that's our process. We manage the conversion of getting them into that recovery environment, but it's all happening in your account. There's nothing hiding anywhere. This also works very similarly if you're doing region to region or AZ to AZ recovery, where we're replicating the data, going into that staging account, and then recovering into the target account. Now, AWS Backup is different, and I'm going to let Yaniv talk about that.
So Mark and I, we can talk all day long about AWS Disaster Recovery and how great it is. We are from the team that builds it, so we're biased. But sometimes, we work hard to get those costs down for the Pilot Lite with the low weight compute and storage resources we use for the staging area. But Pilot Lite is still more expensive than Backup. And you might have tier 3, tier 4 applications that you don't want to pay as much to protect them. The data, they're not as critical. Or you might have resources that you don't have there's AWS Elastic Disaster Recovery cannot protect. So you want to use also AWS Backup. It's also an important point to mention that it's not Backup or DR. It's Backup and DR. As we saw in previous slides, when you have a disaster recovery as a remote copy, you still want to have a backup solution as a vaulted copy. And even so, even when we're not talking about a vaulted copy, we have a lot of customers that use DRS, or Elastic Disaster Recovery, to protect their data for a point in time of every hour for the first few days, and then they use Backup to take lower cost snapshots weekly, monthly, and yearly for compliance. So we see a lot of customers using both, and it's important to understand that it's not mutually exclusive, Backup or DR. So what AWS Backup is, and that's what's really great about it, it's a centralized, fully managed tool. And it's a tool that you can set policies across all the services and resources you have in your AWS account. And when you have only one place where all your resources are centrally being managed, you can understand your compliance structure, and you can run analytics on that and get a lot of insights. So really useful tool. Mostly when we speak about AWS Backup, we speak about backupping resources that are in the cloud, but you can use Storage Gateway and get access from on-premise also as well. So let's take an example of such an application. Let's say a tier 3 application. We have an EC2 instance, we have an EBS volume, and also in our availability zone environment, we have an EFS file system, and we have an RDS database. What we do for basic, as we say, foundational protection, we take a snapshot of the EBS volume, we store it in an S3 bucket. We do the same for the RDS instance. We back up the EFS file system using AWS Backup. Now, let's say the availability zone is down. We spoke about it before. Now, in this case, the S3 bucket has regional availability, so that's not impacted. We can just restore the data to another availability zone. The EFS file system also has regional availability, so we also don't need to do anything. So we basically take the S3 bucket and restore quickly the data from the EBS snapshots and from our database. Now, but what happens if the entire region is down and we want to have cross-region resilience? In that case, and the key here lies in replicating the storage layer. So in this case, the S3 bucket and the AWS Backup. And we can enable cross-region replication for S3 Backup. And then if the region is down, we do the same kind of process. We restore from the S3 bucket the EC2, the EBS volume, and the RDS volume. In this case, we also will need to use AWS Backup to restore the EFS file system. And that's the big difference, because it only has regional availability. But we used AWS Backup to restore from that. So we have a really simple example here. But in a less simple world, you might have data corruption. You might have been impacted by ransomware. And it's not as simple. You need to understand when were you impacted, how you were impacted, and then start responding to that. So there's a lot to do there. So before we speak about more advanced setups for that kind of situation, for cyber resiliency, let's talk about the concept of backup vaults, which is really useful to protect yourself from those cases. And what the backup vault is basically just a logical construct of backup resources. But you can control access to it, and you can lock it, and it gets encrypted separately. And it's really important. So let's see how we can use it in a more complex situation that we want to protect ourselves from ransomware. So in this example, we have a workload account, as usual. And we have resources running in this workload account. What's important in this case, in the workload account, to make sure that all resources are being backupped. Have a backup policy, and all of them are being backed up. That's important. That's the first part. Then we have a concept of a data bunker account. And that is an account with no compute to make it less compromised or gapped. And we just push the point in time, the backups into that. That's the only thing we do. But no compute is running. Now, let's say we use a solution that identified there was a threat. We use logs to understand when was the threat. We understand which point in time we want to restore. What do we do then? Then we start a workflow in that account that didn't have compute before to start restoring that. And the process is to push the data and the point in times into another account. And that's something that we get a lot of questions on. But you have to assume your primary account has been impacted and you were compromised. So we have to be ready for a different account to restore our workloads for this use case. And only once we're impacted, we're starting pushing that point-in-time data into that account. And again, using a backup vault that we push the data into, we can start recovery in that account. So again, the important thing here is you need to understand, to identify that you were impacted with a threat. You need to understand when you were impacted by the threat. But the best thing is to prevent that you be able to get compromised. So AWS has those tools that you see on the screen that can help you with that. We also have great partners with many tools, and there's some sessions that talk about how you do that. So let's put all of that together. And talk back about this concept. We want you to have a local copy. A local copy in the same availability zone, that's your tactical copy. You accidentally deleted something. You did a mistake. You just get it back up, simply, quickly. We wanted to have a remote disaster recovery copy. In this session, we suggested AWS Elastic Disaster Recovery because you can do as many tests as you want. You have low RTO and RPO with a relatively lower cost, and you can do it cross-region. And you also want to have a ransomware recovery copy. You want to be cyber resilient for those situations. So those three layers are the best practices. But what other best practices we want to take from today?
All right. So you've sat here for about 30 minutes What should you be doing tomorrow if you haven't done it already? The first thing I want you to think about doing is making sure that you're tiering your applications. You're tiering them by your business requirements. We can't tell you what tier 1 is. Your business is happy to tell you what tier 1 is. Talk to them. Understand what they think is important and why. The second thing you need to do, test your recovery capabilities. We see a lot of people that test less than once a year. We see a lot of people that test more than once a year. I can't emphasize enough how much you should be testing your recovery capabilities. In fact, I want to overemphasize how much you should be testing your recovery capabilities. Think about how many changes happen in your production environments today, just today. How many times are you patching? How many times are you changing application code? How many times are developers pushing new updates? The amount of changes that are happening are directly impactful to how long that recovery is going to take. And if you don't know, if you haven't tested it, you have no idea. And the fourth thing I want you to be looking at is making sure you're leaving time to troubleshoot in those tests and in those recoveries. We work with a lot of people that go through, do a recovery or do a test, and the systems come up, but not everything works right. You need time to troubleshoot. Think about that in terms of your recovery time objectives as well. You can't guarantee that everything will come up right 100% of the time unless you just happen to have tested it before the last change. So make sure you're leaving time to do that. Now, we've talked a lot about choices. And in fact, we have DR, we have backup, we have compliance. We used to have one way to do all of that. But now, it's not just about one way. You have multiple goals, and sometimes you're going to have multiple tools to do that. The session title is AND. It's about backup and disaster recovery. Depending on how the threat is, depending on what caused the problem, you're going to have a different process for doing that recovery. Make sure you're thinking about that when you're designing your backup and disaster recovery strategies. All right, I want to thank you all for joining us. We're going to be available for questions here after that, or at the end of the session here. And please remember to take the surveys. Thank you all very much.